Hi everyone, in this video we are going to be covering evaluating expressions and factoring. Okay, so let's talk about evaluating expressions. We'll talk about what does that mean, what does it look like, how do we do it. All right, so you will frequently see the phrase evaluate the expression used in math relative to algebra. Right, so evaluating an expression means to find the value of the expression when the variable is replaced by a given number. Okay, so let's focus in on our keywords here. The variable is replaced by a given number. All right, so the variable is being replaced by a given number. Now, what does variable mean? What do you think a variable is? What does variable, the word variable, mean? So variables, think of like if someone asks you a question like, oh, what's the weather like where you live? And you might say, oh, well, it varies. So variable comes from that same word. A variable is a letter that represents an unknown value. All right, so our job most of the time is to find out what is that unknown value, to solve for that variable. All right, so here's an example of an expression. Now, you cannot use the words expression and equation interchangeably. An expression in algebra, an expression is not the same as an equation. We'll talk more about that in a minute. But this is an expression. If there's no equal sign, it's an expression. If there's an equal sign, it's an equation. All right, so here, what is our variable in this expression? 6x plus 2. Right, the variable is x. Right, so x is our variable. In this particular expression, 6 would be called the coefficient of our variable. 6 would be called the coefficient. So 6 is the coefficient. Coefficient is just the number in front of a variable. That says CI. That my handwriting was kind of sloppy there, sorry. CI. There we go. Okay, so 6 is our coefficient. X is our variable. Our operation here is addition, so that plus is indicating the operation. And 2 is just a constant. All right, so we call 2 a constant. So that's where you have a number without a variable, a number that is not attached to a variable. All right, so you see the 6 is attached to the variable, so it's called the coefficient. The number that is not attached to a variable is called the constant. All right, so let's do a little example. Evaluate the expression at x equals -5. We're using that same expression from the last slide. The directions here, evaluate, that means to plug in. So to evaluate means to find the value of that expression at the when you plug in the variable. All right, so evaluate the expression at x equals -5. All right, so we're going to replace x with -5. All right, so that's going to become 6. So right now we have 6 times x plus 2. Okay, so 6 times x, here x is becoming -5, plus 2. All right, so I've got the equal to there just to indicate that those, that this came from the previous line. Here they told me that x is equal to -5, so these two expressions are the same. All right, so now I'm just going to use my order of operations, GEMS or PEMDAS, whichever one you prefer. So remember, GEMS and PEMDAS, that's our order of operations. The G in GEMS tells us to do grouping operations first, like parentheses, brackets, absolute values. Then we do exponents, and then multiplication and division left to right, and then subtraction and addition left to right. All right, same with PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. All right, so here we have multiplication that we need to do first. 6 times -5 is -30, plus 2 just drops down. And then -30 plus 2 would be -28. All right, so that is the value of the expression when x is equal to -5. All right, so easy enough. All right, so let's talk a little bit more about expressions versus equations. Expressions are combinations of numbers, variables, and operation symbols. We just saw that on that last slide. We saw that expression 6x plus 2. So we've got a combination of numbers like 6 and 2, variables like x, and then operation symbols like addition. Equations are made up of two expressions connected by an equal sign. Right, so an equation is where you take that expression and set it equal to another number or another expression. All right, and then one last thing, and then we'll get started with some examples. You may also be asked to solve an equation for a particular variable. Right, so I'm sure you've all seen those directions before, solve for x. And whenever you're asked to solve an equation for a particular variable, what they're really asking you to do is to isolate that variable on one side of the equation and put everything else on the other side of the equation. Okay. All right, so let's get into some examples with expressions and equations and variables. All right, so starting off easy, solve for x. We have 6x plus 2 equals 14. What do y'all think we should do first if we're trying to get x by itself? We're trying to isolate x. The first thing that's standing in our way is this plus 2. All right, so let's move that over first. All right, so we're trying to solve for x, so let's move the 2 over, subtract 2 from both sides. It's going to cancel on the left. All right, so we're left with 6x on the left equals 12 on the right. All right, we're trying to solve for x, so divide both sides by 6 to get x by itself. All right, so we're trying to get rid of this 6, so we're going to divide, because right now we're multiplying by 6, so we can divide to get rid of it. All right, so divide both sides by 6, the 6's cancel, so you're left with x equals 2. All right, so x is isolated, it's by itself, everything else is on the other side of the equation, and so you have solved for x. All right, so here we have a little evaluate the expression problem. All right, so evaluate the following expression for x equals 2, y equals 6, and z equals -3. All right, so let's look at our expression. We have 5x plus negative, and then in parentheses, -2 plus z, close parentheses, minus 9y. All right, so let's start plugging stuff in. So we have 5 times x, right? What was x supposed to be? X was 2, right? So replace that x with 2. So 5 times 2. Right, moving right along. Next we have z. We need to plug in -3 for z. All right, so we're going to plug in -3 for z. So we have plus, parentheses, -2 plus -3, close parentheses. All right, then we have minus 9 times y. Y was 6. All right, so let's plug in 6 for y. So that's minus 9 times 6. All right, cool. So now we've just got to do order of operations. All right, so we're going to do inside the parentheses first, or inside the grouping symbol. -2 plus -3 is -5. All right, now I'm going to do my multiplication. All right, so 5 times 2 is 10. I'm just going to drop that down. So plus a negative 5 becomes a minus 5. And then negative 9 times 6 is negative 54. All right, now I'm going to do my subtraction. That's all I have left. I'm going to do my subtraction just left to right. 10 minus 5 is 5, and 5 minus 54 is negative 49. All right, so that is the value of the expression when x is 2, y is 6, and z is negative 3. All right, next we have a very similar problem. Evaluate the following expression for x equals 3, y equals negative 4, and z equals 12. So new values for our variables. And the expression is 7z minus 5y times 2x. All right, so I want you to try this one. So pause the video, plug in the values, and come back and make sure you get the right answer. Okay, so hopefully you have had time to pause the video and try this yourself. All right, so we're plugging in, let's see, 7 times z, so that's 7 times 12, minus 5 times negative 4, times 2 times 3. All right. 7 times 12 minus 5 times negative 4 times 2 times 3. All right, so let's do our order of operations. We've got to do our multiplication and division first. Here we just have multiplication. So we're going to do it left to right. So 7 times 12 is 84. And then we have 5. So let's just keep track of that up here. Let me switch this and say, okay, that's going to be 84. And now looking at the right-hand side of my expression here, well, let's just do 5 times negative 4, that's negative 20, times 2 is negative 40, times 3 is negative 120. Okay. So 84 minus negative 120. Double negative becomes a positive. Add those together, that becomes 204. All right, so hopefully you got that. Just be careful with the operations. Make sure you're using order of operations. Don't rush through these. Take your time. All right, here we have one that is a little bit more difficult. I say that because it's in a fraction. It's really not. It's really not that much more difficult. It's just maybe more intimidating because it's in the form of a fraction. It says evaluate the following expression for k equals 7, m equals 0, and p equals negative 9. So here I was just picking some random letters just to show you that it doesn't have to be x, y, z or a, b, c. It can be any letters. Anytime you see 0, you want to think like, oh yeah, that's going to make this easy, because if you're multiplying by 0, it's going to cancel it out. If you're adding 0, nothing happens. So you love to see that 0 in there. All right, so here's our expression. It's a fraction. It says negative 8m plus 2k in the numerator divided by 6p minus 4k times 5m. All right, so let's plug in our values. M was 0, k is 7. All right, so m is 0, k is 7. All right, so I've got those plugged in. And then in the denominator, p is negative 9. Excuse me. K is 7, m is 0. So that's going to be 6 times negative 9 minus 4 times 7 times 5 times 0. All right, so now we can do order of operations. We need to simplify the numerator and simplify the denominator separately. So when you're thinking of this, think like, okay, I'm going to start by working up here, and I'm going to simplify that. Then once I've got that simplified, I'm going to go down to the denominator, and I'm going to simplify it. Then once I've got both of those simplified, then I can think of it as a fraction. Right, so just think of it as two separate pieces until you get the tops and bottoms simplified. All right, so negative 8 times 0, that's going to cancel out, right? Negative 8 times 0 is 0. So that cancels out. And then down in the bottom down here, we've got 4 times 7 times 5 times 0. All right, so 4 times 7 is 28. 28 times 5, what is that? That's 140 times 0 makes it 0, so that cancels out as well. All right, so lots of stuff canceling. So let's see what's left. 2 times 7 in the top and 6 times -9 in the bottom. All right, so 2 times 7 is 14. 6 times -9 is -54. But now we need to simplify this. The directions did not say to simplify, so I'll try to be more specific when I put this on the little assessment piece. But you do want to simplify these. 14 over -54, you can just plug that in your calculator and have it simplify it for you, but you could also just notice that 2 goes into both of these. 2 goes into 14 7 times, 2 goes into -54 -27 times. All right, so that's 7 over -27. All right. Now we've got a little bit, this one's actually very similar to the solve the equation that we did, that solve the equation example we did earlier. But this one says solve the equation for k, so different variable, and it's 9k minus 6 equals 48. All right, so what do you think we should do first? So I want you to try this one. It's very similar to the one we did earlier, so you can take a look at that one if you need some direction. All right, so the first thing you're going to want to do is add 6 to both sides. That's going to give you 9k equals 54. And then if you divide both sides by 9, it gives you k equals 6. Right, so that becomes 9k equals 54. Divide both sides by 9, and that gives you k equals 6. All right, little bit of a different style question here. It says solve the equation for t, and we've got all variables. All right, so don't let that intimidate you. We're treating these variables just like they're numbers. That's what they are. They're just representing an unknown value. All right, so we're trying to get t by itself. All right, t is down in the denominator right now. So we need to get t out of the denominator. What can we do to move this t over to the other side? We can multiply both sides by t, right? That's going to cancel it out over here. So it's going to cancel it out on the right-hand side. It's going to get it out of the denominator. And now we can work on getting t by itself. All right, so we've got t times s equals d. Trying to get t by itself. Remember, we're solving for t. All right, so go ahead and get t by itself by dividing both sides by s. It's going to cancel out on the left. And then t is by itself. And then on the right-hand side, we have d over s. So when you have all variables, nothing different. You just treat them just like they're numbers. All right, slightly more difficult. Solve the equation for F. This is the equation for converting between Celsius and Fahrenheit. So we have C equals 5 over 9 times F minus 32. All right, so F minus 32 inside the parentheses. So right now we're trying to solve for F. All right, so that's what we're going for. We're trying to get F by itself. The barrier right now is this 5 over 9 in the front. Right, so how do we get rid of 5 over 9? How can we move it to the other side so that we can get F by itself? What could we do to get rid of 5 over 9? Y'all might remember this from, from your last algebra class, but if you want to get rid of a fraction, if you want to move a fraction to the other side, you can multiply both sides by its reciprocal. Right, so you can, let me erase this. Okay, so you can multiply both sides by the reciprocal of that fraction to cancel it out. Right, so I'm going to multiply by 9 over 5, multiply by 9 over 5. Whatever I do to the right-hand side, I've also got to do to the left-hand side. Right, so that's going to make those 9's cancel. So we got a 9 in the top, 9 in the bottom, and then a 5 in the bottom, 5 in the top. So 5's are going to cancel. So 9's cancel and 5's cancel. So we're left with 9 over 5 times c. And then on the right-hand side, we've just got f minus 32. So you see I've dropped the parentheses because I've gotten rid of that fraction out front. And now I'm trying to get f by itself, so the last thing standing in my way is this 32. So I need to add 32 to both sides to get f by itself. That cancels out on the right. And we have f equals 9 over 5c plus 32. And I know some of y'all have told me you prefer to put what you're solving for on the left, so if you write it this way, that is fine. So those two answers are the same. All right, so let's get into factoring. Factoring is probably the most challenging part of today's lesson. We're going to be really reviewing how to factor numbers using our little factor trees. Hopefully you learned how to do that in Math 2008, Numbers and Operations. Factoring is a really important process in algebra, which is used to simplify expressions, fractions, and solve equations. Right, so factoring is a really important process, helps us to learn how to, alter expressions and fractions, and helps us solve equations. So if you will recall, prime versus composite. Do y'all remember what prime and composite mean? A composite number is a number that can be written as the product of two positive integers other than one in itself. So an example of a composite number is 4, because 4 can be written as 2 times 2 or 4 times 1, right? So 1 times itself. All right, so 4 is a composite number. A prime number is any number that's greater than 1 which has only two positive factors, 1 and itself. All right, so an example of a prime number would be 3. The only factors of 3 are 1 and itself. Right, factors means what multiplies to give you that number. So a factor, so if you say the factors of 16 are, the factors are the values or the numbers that multiply to give you some value, some other value. All right, so let's recall and jog your memory about how to do these factor trees. All right, so I like to use factor trees to find the greatest common factor of two numbers. You can use other methods if that's what you prefer. Just make sure you show your work. It says find the GCF, which is the greatest common factor. All right, so GCF is greatest common factor. So what is the largest number? What is the largest factor that they have in common? What is the largest factor that they have in common? All right, so we're going to make little factor trees for 102 and 51. All right, so let's start with 102. 2 definitely goes into that, right, because it ends in 2. What is 102 divided by 2? That would be 51, right? 51 times 2 gives you 102. Right, 51, does that have any factors or is it prime? It does have some factors. It's 17 times 3. There's a bunch of little tricks if y'all remember, or not tricks, but little rules for how do you check for factors. So I want to say to check if 3 is a factor, you add up the digits, and if it's divisible by 3, then the number itself is divisible by 3. So 5 plus 1 is 6. 6 is divisible by 3, so that tells you, okay, 51 is divisible by 3. If you don't remember those from Math 2008, you can Google those. I would search something like rules for checking factors or something like that. Let me see. I'm going to Google that and see if it comes up. For checking factors. Yes. Oh, okay. They're called divisibility rules. Divisibility rules. You might need to brush up on those. Divisibility rules. So if it's been a while since you've learned about these divisibility rules, you may want to Google those. All right, so now we are down to 17 and 3. 17, let's see, does 2 go into it? No. 3, no. 17 is prime, so it can't go any further. So that means we can write 102 as 2 times 3 times 17. 2 times 3 times 17. That's the, it's prime factorization. Do y'all remember that? Prime factorization. Right, now, let's do a factor tree for 51. Well, we've already done a factor tree for 51. It's right there. We just found out that 51 is 17 times 3. 17 is prime, 3 is prime. So 51 is 3 times 17. All right, so their greatest common factors, you're just going to look at the two prime factorizations and figure out what do they have in common. All right, so here we've got 3 in common and 17 in common. All right, so that's the prime factorization. Is 3 times, excuse me, that's the greatest common factor. Is 3 times 17, which is 51. So just to recap what we just did there, you take both of the numbers, you make a little factor tree for them. Then you write them in their prime factorization form. I like to do smallest to biggest, just to keep them in order. So I do the smallest factor, the next smallest factor, next smallest factor, next smallest, and and so on. So I've got 2 times 3 times 17 is the prime factorization for 102. And then for 51, the prime factorization is 3 times 17. So then you compare these two and say, what do they have in common? We're looking for the greatest common factor. So what do they have in common? They both have a 3 in common, and they both have a 17 in common. So we pull both of those down into our greatest common factor and multiply them. And that becomes our greatest common factor. Let's try this one more time. I want you to take a second, pause the video, and try this on your own. I'm going to give you a second to pause the video just in case you are in the middle of writing. So make your little factor trees for 153 and for 21. So hopefully you've had enough time now to pause the video. I'm going to make the factor tree. 153, 3 definitely goes into that. You can see, let's see, 5 plus 3 plus 1, that's 9. 9 is divisible by 3, so 153 is divisible by 3. All right, I would break that into, let's see, that's 51 times 3. We just did 51 a minute ago. We know that 51 is 17 times 3. And we know 17 is prime, 3 is prime, 3 is prime. So that's the prime factorization, is 3 times 3 times 17. Now for 21, this one's easy. 21 is 7 times 3. 7 is prime, 3 is prime. So there's my prime factorization. Now I got to figure out what do they have in common is the greatest common factor. Right, so they both have a 3, right? And that's it. That's the only thing they have in common. They both have, oop, let me try that again. I don't know why I highlighted the second one. Let's highlight the first one. Right, they both have a 3 in common. That's the only thing they have in common. So the greatest common factor is 3. All right, let's increase the difficulty level just slightly. Here we've got a combination of numbers and variables. All right, so we've got find the greatest common factor of 6a squared and 10ab cubed. All right, so just start by looking at the numbers. 6 and 10. Prime factorization for 6, let's see, that breaks down into 3 times 2. 3 and 2 are both prime. So the prime factorization for 6 is 3 times 2. 10 gets broken down into 5 times 2. Right, so we've got 6, whoops. Right, 6 is 3 times 2. 10 is 5 times 2. And you see I've got them written in the wrong order here. I just said I was going to do them smallest to biggest. Let me try that again. 2 times 3 and 2 times 5. All right, then you ask yourself, what do these prime factorizations have in common? They both have a 2, right? All right, so the greatest common factor is 2. All right, so now we've taken care of the 6 and the 10. All right, we've taken care of the 6 and the 10, so now we're looking at the variable portion. We're looking at a squared and ab cubed. What do those two expressions have in common? What do they have in common? They both have an a, right? Do they both have a b? No, they do not. This one over here does not have a b. This one over here does have a b. All right, so this one has 2 a's. It's a squared, so it's really a times a. How many a's does this one have? Just the one, right? This one has 3 b's and 1 a. So what do those two pieces have in common? You can think of like this as a times a would be its prime factorization. Right, and this one would be a times b times b times b. All right, so what do they have in common? They both have 1a in common, right? All right, so the GCF is a. Let me erase that I wrote. There we go. So just put those together. The GCF of the number part was 2. The GCF of the variable part was a. So the GCF is 2 times a. Remember, factor, we're multiplying, so that's why we multiply those together. Factor means multiplication. All right, a little bit more difficult, but I know that you can do this, so I want you to try this one. Pause the video. Come back and check your work in just a minute. All right, do it the same way. Do the greatest common factor of the number portion, so 75 and 4, and then look at the variable portion and see what do those have in common. All right, so 75 and 4, what'd you get for the GCF of 75 and 4? Just 1, right? There's nothing, they have no factors in common other than 1. All right, so no number portion needs to be written down. But what about the variables? They both have an x, they both have a y, but how many should we include? How many do they have in common? This one's got 3 x's, this one's got 2 x's, this one's got 5 y's, this one's got 4 y's. All right, so they have 2 x's and 4 y's in common, so x squared and y to the 4th. So 2 copies of x and 4 copies of y are in common. All right, so we're taking it one step further, and this time instead of just identifying what is the greatest common factor between 3 terms, this time we're going to factor out a greatest common factor. Remember, factor means multiplication, so we're going to be pulling this out front and saying, okay, you can multiply through by this factor to get to this expression. All right, so let's just look at each expression individually. We've got 15x cubed, and then negative 25x squared, and then 55x. They definitely all have an x in common, right? I see an x in the first one. We have 3 x's in the first term, 2 x's in the second term, 1 x in the third term. So they definitely have an x in common. But what about their numbers? 15, 25, and 55. What goes into all of those? And if you don't know right offhand, that's okay. Do a little factor tree for each one. So you could go off to the side and do a little factor tree for 15, and a little factor tree for 25, and then a little factor tree for 55. All right, so 15 would be 3 and 5, 25 would be 5 and 5, 55 is 11 and 5. Let's see. 3, 5, 5, 5, 11, 5. Those are all prime numbers, right? So what do those factor trees have in common? A 5, right? So we're going to pull out a 5 and an x. All right, so we're going to pull out a 5 and an x. Let me just erase this. Okay. All right, so pull out a 5 and an x, and then you divide by 5x to see what's left over. So you do 15x cubed divided by 5x, right? Why are we dividing? Because we're factoring it out. So we're doing the opposite operation so that we can get it outside of the parentheses, so that way when you multiply it back through, it'll match this top line. All right, so 15x cubed divided by 5x, 15 over 5 is 3. 3 x's take away 1 x gives you 2 x's left over. Then negative 25 divided by 5 is negative 5. 2 x's take away 1 leaves you with 1 x. 55 divided by 5 is 11. 1 x take away 1 x, x's are gone. Right, so this is what it looks like to factor out the GCF. Right, you can see my parentheses is accidentally popping up here. That's okay. All right, so it says factor out the GCF. We're looking at 72a to the 5th minus 8a cubed minus 80a squared. I want you to try this one, so pause the video, figure out what is the greatest common factor, and then pull it out in front, then divide through by that greatest common factor to figure out what's left inside the parentheses. All right, so what is the greatest common factor between 72, 8, and 80? Oh, this one actually might be kind of tough if you do it with factor trees. I didn't think about that. Actually, no, it won't. No, it won't. I'm lying. Okay, so 72 is 9 times 8. Those can both be broken down further. 9 is 3 times 3. 8 is 4 times 2. 2 can be broken down again into 2 times 2. 8 is 4 times 2. 4 gets broken down into 2 times 2. 80 is 10 times 8. 10 goes down into 5 times 2. 8 goes into 4 times 2. 4 gets broken down again into 2 times 2. All right, so that's the factor trees. Your GCF, what do they have in common? Well, it would probably be easier if we wrote out the prime factorizations. 72 is, let's do 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 3 times 3. 8 is 2 times 2 times 2. 80 is, I'm going to write it, 80 is 2 times 2 times 2 times 2 times 5. So 4 2's and a 5. All right, so then you say, what do they have in common? Let's check. They've definitely all got a 2. Okay. Do they all have another 2? Yes, they do. Do they all have another 2? Yes, they do. Do they have anything else? Nope, that's it. 2 times 2 times 2. 2 times 2 times 2, which is 8. All right, so pull out an 8. What about the A's? How many A's do they have in common? How many A's do they have in common? They each have 2 A's, right? That's how many they have in common. So we're going to pull out 8A squared. What's left inside if you divide by 8A squared? 72 divided by 8 is 9. 5 A's take away 2 gives you 3. Negative 8 divided by 8 is negative 1. 3 A's take away 2 gives you 1 A left over. Negative 80 divided by 8 is negative 10. 2 A's take away 2 A's. A's are gone. All right, last factor out the GCF example, I think, is 6x squared yz plus 2xy squared z minus 4xyz. All right, so look at your numbers, 6, 2, 4. What do those have in common? What factor? Yeah, 2 goes into all those. And what about the variables? They each have an x, they each have a y, and they each have a z. So we're going to pull out 2x, y, z. If you pull out a 2x, y, z, divide through by 2x, y, z, what you're left with is 3x from the first term, y from the second term, and negative 2 from the last term. Right, so 6 divided by 2 is 3. Take away the y's, take away the z's, take away 1x, you're left with just an x. Next one, 2 divided by 2 is 1. Take away the x, take away one of the y's, take away one of the z's, so we're left with just a y. The negative 4 divided by 2 is negative 2. Take away x, take away y, take away z, all the variables are gone. Oh, I lied, sorry. We have another factor out the GCF. Right, you try this one. Right, so take a second, pause the video. I'm not going to explain this one in depth because this is our 4th one that we've done. Right, so our GCF is negative 4x squared y. If you didn't do negative 4, if you just did positive 4, that's fine. You could argue for either way. It doesn't really matter to me one way or the other. I factored out a negative so that this first term would be positive. That was really the only purpose. Right, so I did negative 4x squared y, and when I divided everything by that, I was left with 4xy minus 6y squared plus 8x squared. So you can see the signs flipped. This one became negative, this one became positive. That was because I factored out a negative. All right, so our next topic is factoring by grouping. Factoring by grouping. Right, so factoring by grouping, when you are asked to factor an expression that has 4 terms, you want to immediately think of factoring by grouping. So factoring by grouping is a factoring technique that is specifically designed for expressions with 4 terms. All right, and these are the steps for factoring by grouping. You're going to start by checking the entire expression for a greatest common factor. So maybe 2 goes into every term. That's just going to bring your numbers down. It's going to make your numbers easier to work with. Right, the second step is to split the expression into 2 groups. Now, sometimes you might have to reorder the expression to get this to work perfectly, but just start by doing the first 2 and the second 2. And if that doesn't work, you can try reordering things. Step 3 is to factor out the GCF, or the greatest common factor, from the first group. So you just look at just the first group, and then you factor out the GCF. Then you're going to repeat that process for the second group. So factor out the greatest common factor from the second group. Right, next, you're going to make sure that the expressions that are inside your parentheses match. If they don't, then you did something wrong. All right, so check that the expressions inside the parentheses match. Because if they don't match, then you did something wrong. And the last step is to pull out the common factor. The leftover stuff goes in a second set of parentheses. So you're going to see what that means in just a second. Let's look at an easy example to start with for factoring by grouping. You can see that we have 1, 2, 3, 4 terms. So since I've noticed that we have 4 terms, I know that I'm going to do factoring by grouping. All right, so I'm going to start by looking at each term and saying, okay, is there anything that goes into each one of these? Do they all have an x? Are they all divisible by 2? Are they all divisible by 5? All right, so let's check. This one's got 5, 25, 2, and 10. Is there anything that goes into 5, 25, 2, and 10? No, unfortunately the 2 messes that up. All the other ones are divisible by 5 except for that one. So there's no number that I can take out, but let's look at the variables. We've got x cubed, x squared, x, and then no variable. So there's nothing that we can take out. There's no greatest common factor. All right, so then we go to the next step, which is to split the expression into 2 groups. So I'm just doing first group. The first 2 is my first group. Second group is my second 2. All right, so first group, second group. Right now, I am going to factor out the greatest common factor from the first group. And while I do that, I am just ignoring this stuff over here. So just pretend like that doesn't exist. All right, just look at the first group. 5x cubed and 25x squared. What common factor do these two terms have? 5 goes into both of them, right? And what about the x's? How many x's do they have in common? X squared, right? So they both are divisible by 5, and they both have an x squared. All right, so let's pull out a 5x squared. Sorry, everything was not supposed to just pop up, but let me see if I can hide this. Okay, just hiding all this for right now. Don't look at that. Sorry about that. Okay, so we said that our common factor was 5x squared. When you divide these first two terms by 5x squared, 5 divided by 5 is 1. 3 x's take away 2 gives you just x. 25 divided by 5 is 5. 2 x's take away 2 x's, x's cancel. All right, so now your next step is to factor out the greatest common factor from the second pair. Right, so now we're doing the opposite. We are ignoring that first chunk of information. So we're just looking at the second group. Right, so we're just looking at the second group. Right, 2x plus 10. What do these two terms have in common? What is their common factor? They both have a factor of 2, right? So you're going to pull out a 2. And notice that I've indicated that it's positive here. That's important. You're pulling out a positive 2. So make sure you indicate there that that's a positive 2. And if you divide by positive 2, 2 divided by 2 is 1. X take away, or excuse me, we're not taking away any x's, so just dividing by 2, so that leaves you with x. 10 divided by 2 is 5. All right, so now we look at everything as a whole, and we're supposed to make sure that the expressions inside the parentheses match. And they do. They both are x plus 5. All right, so now that's considered a common factor. Each one of these expressions is being multiplied by x plus 5, so it is considered a common factor. That piece goes out front. All right, so the x plus 5 goes out front. In the second set of parentheses, I'm going to put the leftover stuff. All right, so the leftover stuff is what's left over aside from the x plus 5. So that's 5x squared plus 2. All right, so that goes in the second set of parentheses, 5x squared plus 2. Then if you wanted to check your answer, you can FOIL this back out. Remember, FOIL stands for first, outer, inner, last. That tells you how to multiply this out. So you start by multiplying the first terms, then the outer terms, x times 2, then the inner terms, 5 times 5x squared, and then the last terms, 5 times 2. And if you multiply that all out, combine like terms, it's going to get you back to the original. All right, so you can check your answer using the FOIL method. All right, so let's do a second example with factoring by grouping. We are looking at the 4 terms, so we know we're going to do factor by grouping. We are separating this into the first group and the second group. Remember, we are essentially just ignoring this second group for a moment. We're just focusing on the first group. 15x cubed plus 40x squared. What do those have in common? Does 5 go into both those? Yes, it does. 5 goes into 15 and 5 goes into 40. And they both have x squared in common. So we're going to pull out 5x squared. When you do that, when you divide everything by 5x squared, 15 divided by 5 is 3. 3 x's take away 2 x's gives you 1x. 40 divided by 5 is 8. 2 x's take away 2 x's, x's are canceled out. All right, so now you are going to ignore the first group. So just ignore this. And we're just looking at the second group. -6 and -16. What factor do they have in common? They both have a 2 in common, right? 2 goes into both of those. And even more than that, a negative 2 goes into both of those because both of these are negative. So I'm going to pull out a negative 2. So I'm going to divide by negative 2. Negative 6x divided by negative 2 is 3x. Negative 16 divided by negative 2 is positive 8. All right, so now we have factored out the common factors. We're supposed to check and make sure the stuff inside the parentheses matches. It does. So we know we're on the right track. So that's now considered our common factor. So our common factor gets pulled out front. And then our leftover stuff goes in the second set of parentheses. So 3x plus 8 times 5x squared minus 2. Right, so the 3x plus 8 comes from here and here. That's the common factor that gets pulled out. And then the 5x squared minus 2 goes in the second set of parentheses. All right, so I want you to try this one. So take a second, pause the video. If you're not ready yet and you need to see another example, that's okay. You can see I've split it into first group, second group. I'm just looking at the first group and I'm saying, okay, what do those have in common? 2 goes into both of those, and t squared goes into both of those. So I'm going to factor out a 2t squared. That leaves me with 2t minus 1 inside the parentheses. All right, so 4t cubed divided by 2t squared. 4 divided by 2 is 2. 3 t's take away 2 t's leaves you with 1 t. And then negative 2 divided by 2 is negative 1. T squared divided by t squared is, those cancel, so no t's. All right, then looking at the second group, negative 18t plus 9, what goes into both of those? We need to make it match the inside of the parentheses, so we need to factor out a negative 9. That's going to give us the 2t minus 1 in the parentheses, matching like we want them to. All right, then there's the leftover stuff. So we've got 2t minus 1 times 2t squared minus 9. So the 2t minus 1 is the common factor that was inside the parentheses. The 2t squared minus 9 comes from the leftover stuff. All right, so let's get into the last part of this lesson, which is factoring basic trinomials. In this class, we're just going to be considering the case, the most basic case. So here you can see this is a trinomial. It's called a trinomial because it has 3 terms. Tri means 3. Nomial comes from the polynomial. That's just the general word we use to describe expressions that look like this. All right, so we're going to be considering the most basic case where a is 1. All right, so this variable here, or this coefficient will be 1. All right, so our trinomials will look like this. They'll say x squared plus b times x, b will be some number, plus c, which is our constant, and c will also be a number. So b and c will be replaced by numbers. Your factors, whenever you factor this trinomial, your factors will have the form parentheses x plus blank, close parentheses, and then the same thing again. So parentheses x plus blank, and then a second set of parentheses. All right, so your job is to find the numbers that go in the blanks. All right, so you have to find the numbers that go in the blanks that when you multiply this back out, you get back to the original trinomial. All right, so here is the criteria that you have to follow to figure out what numbers go in the blanks. The numbers that go in the blanks, whenever you add those two numbers, they have to match the middle coefficient b. All right, so when you add the numbers, they need to add to b. And the numbers, when you multiply them, must multiply to equal c. All right, so they have to multiply to c and add to b. All right, so let's look at an example. Directions just say factor completely. It says x squared plus 5x plus 4. Right, so I like to just start by writing out what my factors are going to look like. So that's going to be equal to my little sort of template here, parentheses, x plus blank, close parentheses, and then parentheses, x plus blank, close parentheses. So this is what I'm going to call my little template. Now we're supposed to figure out what numbers go in the blanks. And to do that, I like to use this little table. There's lots of different ways that you can do it. If you're good at doing these in your head, by all means, you do not need to write down the table. But if it's been a while since you factored, then you may want to write out the table for each problem. All right, so here's our little table. It's just 2 columns, and it says pairs of factors and then sums of factors. So the pairs of factors, that's all the numbers that multiply to equal 4. Right, so all the numbers that multiply to equal that constant 4. And then the sums of those factors are supposed to add to the middle coefficient, remember? So they're supposed to add to equal 5. All right, so we're looking for things that multiply to give you 4 and add to 5. All right, so what are some things that multiply to give you 4? 1 and 4, and what else? 2 and 2. All right, so those are the numbers, or the factors, the pairs of factors, that when multiplied give you 4. Now we need to come over here and add the factors together to see which ones sum to 5. All right, so 1 plus 4 is 5, 2 plus 2 is 4. All right, so we were looking for 5, so that's the one we were looking for. So that's our factor pairs. So there's our numbers that go in the blanks, 1 and 4. It does not matter if you put the 1 first or the 4 first. Either way is fine. So here you can see I've put in the 4 in the first blank, 1 in the second blank. It is totally fine if you did it the opposite way like this. That is the same thing. So both of these are the same. All right, so let's try this again. X squared plus 13x plus 22. So we're looking for the 2 numbers, the factor pair, that multiplies to give you 22, but adds to 13. Right, going to start off with our template, make our table. So things that multiply to 22 and add to 13. What are things that multiply to 22? 22 and 1 and 2 and 11. All right, so add those up to fill in the second column, the sums of the factors. 1 plus 22 is 23. 2 plus 11 is 13. That's what we were looking for. We were looking for 13. So that's our factor pair. So now we're just going to put those numbers in the blanks, 2 and 11. If you put the 2 first, that's fine. If you put the 11 first, that's fine. Let's see what I did. Yep, I put the 2 first. All right, but again, you could also write it as x plus 11 times x plus 2. Same thing. All right, let's try again. All right, a little bit more difficult. Do your template. We have x squared plus x minus 42. Make your table. We're looking for numbers that multiply to give you not 42, right, but negative 42. So things that multiply to give you negative 42, and what are they supposed to add to? What's the coefficient here on the middle term? What's the coefficient on x? There's nothing there, right? So we can assume that that's a 1. Right, so there's an understood 1 there. So there's an understood 1 right there. All right, so things that multiply to give you negative 42 and add to give you 1. All right, so if we're supposed to be multiplying to give you a negative number, one of the factors is going to have to be negative. So we could do negative 1 and 42, or you could flip it and do 1 and negative 42. What else goes into 42? Probably what's the first one that comes into your mind? 7 and 6? Yes, 7 and negative 6. That would multiply to give you negative 42. And let's flip them around and do negative 7 and positive 6. Right, so all these would multiply to give you negative 42. All right, we're looking for the ones that add, the factor pair that adds to 1. All right, so let's add these together. Again, you're just kind of putting a little plus sign in between them. All right, so -1 plus 42, that's the same thing as saying 42 minus 1. So that's -41, or excuse me, 42 minus 1 would be positive 41. The next one, 1 plus a -42, that's -41. 7 plus a -6 gives you +1. That's what we were looking for. You can fill in the rest of the table if you want to. You don't have to. That was -1. But once you find the number, you can stop filling in the table. All right, so we were looking for 1. That's what we got here. So we were looking for 1. That's what we got. So that's our numbers, 7 and -6. 7 and -6. Now, I do want you to simplify this. So if you have a plus and negative or a double negative, I always want you to simplify that. So the x plus 7 is fine. It's going to stay the way it is. And then x plus -6, that's just going to become x minus 6. And again, if you wrote this in the opposite order, so if you did x minus 6 first and then x plus 7 second, that is totally fine. What's not fine is you could not do x minus 7. So you could not do x minus 7 and x plus 6. Okay, that's the wrong factor pair. That adds to -1. We were looking for it to add to +1. All right, so just be extra careful there. I'm trying to show you all the ways you could write the answer, but I know that also can create some confusion. All right, let's look at another one. This one doesn't look too bad. X squared minus 5x plus 6. Do your template, do your little table. So we're looking for things that multiply to give you 6 and add to what? What are they supposed to add to? The middle number, the coefficient on the middle term, which is -5. All right, so things that multiply to give you 6. 2 and 3, right? You could also do 1 and 6. 2 and 3 multiply to give you 6. What else multiplies to give you 6? Because these are going to add to 5, right? We need -5. Things that multiply to 6. What about -2 and -3? A negative times a negative is going to give you a positive. All right, so that's okay. And let's see what they're going to add to. 2 plus 3, we said added to 5. And -2 plus -3 adds to -5, which is what we were looking for. So that's our numbers, -2 and -3. So let's plug those in. Then simplify. So that becomes x minus 2, x minus 3. Okay. X squared minus 2x minus 80. Do your template, do your table. All right, so things that multiply to give you -80, multiply to give you -80, and add to give you -2. All right, so multiply to give you -80 and add to -2. What are some things that multiply to give you -80? I was thinking -40 and 2, or you could flip it around and do +40, -2. What else? 10 and 8, right? So it's got to be negative. So we'll do -10, +8, +10, -8. All right, so let's add those up. -40 plus 2 would give you -38. 40 minus 2 gives you +38. -10 plus 8. So remember, you're really just adding like a little plus in between here. That's what I'm doing. -10 plus 8 is -2. That's what we were looking for, right? I went ahead and filled in the last one, but you really don't have to. Once you find the number you're looking for, you don't need to finish the table. All right, so there's my factors. I need to plug those numbers in, -10 and 8, -10 and 8. And I'm going to simplify this first term. I'm going to make that x minus 10. All right, and our last one, I saved an easy one for last. We have x squared plus 10x plus 24. Do your template, do your table. These numbers are supposed to multiply to give you 24 and add to 10. So multiply to give you 24 and add to 10. What are some things that multiply to give you 24? 1 and 24, of course. 2 and 12. 3 and 8. 4 and 6. All right, so let's add those together. So remember, we're really just taking and adding these together. It's that simple. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. That's what we were looking for. We were looking for 10. All right, so there's our factor pair. 4 and 6, that's our numbers. So let's plug those into our template and our little blanks. 4 and 6. And nothing needs to be simplified, so you are all done. I really appreciate you watching this whole video. I know it was a long one. I know it was a challenging one, and maybe outside of your comfort zone, but I really appreciate you, working hard and giving it everything you got. So please let me know if you have any questions, and I'll be happy to help you out. Otherwise, I'll see you guys in the next video.